What if a web scraper could run itself? No manual trigger, no babysitting, and no database to maintain. In this video, we're going to build exactly that, using Anthropic's Claude Managed Agents. We'll set up an agent that wakes up on a schedule, remembers what it saw last time, compares it to today's prices, and reports what changed. We'll also see where the agent genuinely earns its place, and where you may still need real data infrastructure to make it work. I'm Manthvidis from Oxylabs. Let's get straight into it. Quick context, because this platform is brand new. Claude Managed Agents sit in the middle of the automation spectrum. On one end, we have no-code triggers like N8N, easy but quite rigid. On the other, raw terminal setups like Claude Code give you total control, but you have to host and maintain everything. Managed Agents split the difference. You define the agent, and Anthropic runs the container, the scaling, and the infrastructure. Before we build, you may ask, why use an agent at all? A standard scraper is just a script, which makes it fast and predictable. What you are buying with an agent is judgment. It decides which price changes are worth reporting, what to do when a selector moves, and how to recover from an error. That's the trade-off, swapping absolute predictability for adaptability. We'll come back to this point at the end of the video, and it'll make much more sense. There are 4 quick concepts to know before we build. The agent is the persona, meaning its instructions and tools. The environment is the room it works in with, container, network, and credentials. A session is a single run where the agent executes. And finally, events are the stream of what it actually did, like every tool call, result, and error. Let's not forget the pricing. You pay standard token rates plus 8 cents per session hour, but only for active runtime. Idle time is free. One important note, this bills against API credits in the console, so your Pro or Max subscription doesn't cover it. We'll work from the CLI using the Ant tool, because that's how you'd actually ship this to production. Let's confirm it's installed. First, we'll create the agent. We're giving it the standard agent toolset, bash, file editing, the basics, along with one main instruction set. Scrape our target pages, compare them against memory, and report what changed. That returns an agent ID we'll use throughout the process. Then, the environment. The key setting here is networking. We're starting with unrestricted access so the agent can reach the open internet directly. Remember that choice. It will matter later. Before prompting anything, let's take a look at what we're scraping. We'll use the Oxylabs Sandbox, which is a product catalog built like a simple e-commerce website. Each item here has a name and a price. Opening DevTools, you can see every product sits in a repeating card with predictable class names. This is important because while AI accelerates scraping when used correctly, it doesn't remove the need to understand the underlying page structure. Now for the actual build. We'll use a short SDK script to create a session, send the job, and stream the events as they happen. We only change 3 things per run: the environment, whether memory is attached, and the prompt. And there it goes. It fetches the page, writes a parser, runs it, and gets the products out. This is the best part. It reads its own errors, adjusts, and reruns when needed, and we don't even need to tell it to do that. We get clean JSON output. Naturally, on a static sandbox, this works perfectly. But now let's point it at a real target. We'll use the same agent and approach, but this time we're pointing it at Amazon. Instead of just one page, let's try to fetch 15 product URLs back to back. The first request comes back clean, and so does the second. But watch what happens by the 5th or 6th. Error 500, bot detection, rate limiting. The more it hammers those requests, the worse it gets. Every retry is also tokens and session hours wasted. Our agent is literally burning money to get blocked. To be fair, the agent isn't the problem here. It's great at logic and memory, but it doesn't have the proxy infrastructure needed to scale beyond a couple simple calls. This is exactly the gap that data infrastructure fills. Claude Managed Agents support credential vaults, which let you register API keys so the agent can use them without ever reading, logging, or leaking them. I'm putting our Oxylabs web scraper API credentials into a vault, locked strictly to the Oxylabs endpoints only. Inside the container, the agent just sees a placeholder. The real credentials are only injected at the network boundary when requesting the domains we allow listed. Now we switch to the lockdown environment we mentioned earlier, limited networking, restricting access to Oxylabs endpoints only. It's the same job with one change. Instead of aiming at Amazon directly, the agent calls the web scraper API using URL lib and sets the source to Amazon. The data comes back rendered, unblocked, and beautifully structured. We didn't have to write any proxy code, no retry logic, or CAPTCHA handling. Now the agent handles only the logic, and the API handles the whole delivery mechanism. There's one more option here. Right now, I am writing that API request by hand, which gives me finer control. But Oxylabs also offers an MCP server. It's the same data layer, except the tools get handed directly to the agent, so it can choose when to use them. Essentially, you can handwrite requests when you want strict control, or use MCP when you want the agent to decide. You can find the MCP link in the description below. With everything we have right now, this next step is what separates a basic scraper from an autonomous application. Normally, every session starts fresh. When a session ends, all context is gone. So if this agent runs tomorrow, it would have no idea what it saw today, making the whole change tracking impossible, unless we give it a memory store. A memory store is a document collection that lives outside the session. It gets mounted into the container as a directory that the agent can read and write to. While the container gets destroyed after the run, the memory still survives. We're seeding it with a baseline snapshot, representing what the store would contain after last night's run. To be clear, since the Sandbox prices are static, so I wrote this baseline by hand to guarantee a clean and noticeable price delta. Everything the agent does with it from here on out is real. With memory in place, we can set up the schedule. We define a cron expression, attach the agent and environment, and, most importantly, link the memory store as a resource. This guarantees that every run gets the same memory mounted. Each scheduled run is a brand new session, but the memory carries across the whole project. Let's let it fire. Here's the sequence. First, it mounts the memory and reads yesterday's prices from MNT, memory, price history, prices.json. Then, it scrapes today's prices, diffs them, and writes the new snapshot back. It should catch all price drops, increases, and new products. We didn't need to build a database or even write any complex state logic, since the memory store handles everything. If you want to trigger this from your own systems instead of waiting for a cron schedule, the API flow is simple. Create a session, send it a message, poll or stream until it finishes, then read the messages back. Any backend, webhook, or cronbox tool can drive this. So, where does this workflow land? Managed agents are very useful when the job involves judgment. They're great at deciding which price changes matter, adapting when a layout shifts or errors appear on the fly, holding memory state without a database, and running autonomously. What they don't do is out-engineer a competent bot traffic system, though that's mostly an infrastructure problem. And if your job is fetching the same 50 URLs every day at the same time in the same format, a cron job and 30 lines of Python code is usually a better bang for your buck. And with that, we successfully built an agent that runs itself on a schedule, remembers what it saw last time, and reports what moved. Claude handled the logic and memory, while Oxylabs handled the data delivery. If you want to try this yourself, the Managed Agents Quick Start and the Oxylabs Sandbox are both linked below. Everything up to the memory store takes about 20 minutes and costs almost nothing to run. Then try your luck with other targets and track all the price changes effortlessly. If you have questions about the API, email support@oxylabs.io or use the live chat on our homepage. Thanks for watching, hit that like and subscribe to not miss more videos like this one, and see you in the next one.